Have you ever looked up at the night sky and wondered just how big everything out there really is? Well, today we're going to talk about our closest galactic neighbor, the Andromeda Galaxy, also known as M31. And trust me, when we say big, we mean mind-blowingly, incomprehensibly massive. So buckle up, because we're about to take a cosmic journey to understand the true scale of this galactic giant. First, let's talk about its sheer physical size. When you measure it from one end to the other, the Andromeda Galaxy spans approximately 220,000 light-years. To put that into perspective, our own home, the Milky Way, is about 100,000 to 150,000 light-years across. This means Andromeda is nearly twice as wide as our galaxy. Here is a fun fact. If our eyes were sensitive enough to see the entire galaxy in the night sky, Andromeda would appear wider than the full moon. What we typically see, even with a small telescope, is just its bright, glowing central core. The rest of its vast, faint arms stretch far beyond that. Imagine looking up and seeing this colossal structure looming over us. It's a humbling thought. Now, a galaxy isn't just empty space, it's filled with stars. And in this department, Andromeda is an absolute behemoth. While our Milky Way is estimated to have somewhere between 100 to 400 billion stars, which is already a number that's hard to wrap your head around, Andromeda blows that out of the water. It's estimated to contain around 1 trillion stars. That's a 1 followed by 12 zeros. 1 trillion suns, each potentially with its own system of planets. This means Andromeda has anywhere from 2 to 5 times more stars than we do. It's a bustling metropolis of stars compared to our already sprawling cosmic city. Just think of the sheer number of worlds and possibilities that exist within that one galaxy. But when astronomers talk about how big a galaxy truly is, they often focus on its mass. This is where the story takes an interesting twist. The total mass of Andromeda is estimated to be between 800 billion to 1.2 trillion times the mass of our Sun. That's an immense amount of gravitational pull. However, there's a catch. Most of this mass, for both Andromeda and the Milky Way, isn't in the stars, gas, and dust that we can see. It's locked away in an invisible, mysterious substance called dark matter. This dark matter forms a massive halo around the galaxy, dictating its structure and how it spins. When you strip away the dark matter and compare only the visible, normal matter, the stuff that makes up stars and planets, the two galaxies are surprisingly similar. In fact, some recent studies suggest that our Milky Way might even have a slight edge in terms of normal matter, possibly because we have a denser, more massive central region. So, while Andromeda is physically wider and has more stars, in the cosmic heavyweight championship of mass, it's a much closer fight than you'd think. You could almost call them cosmic equals, or at least very close contenders. So, why does all this measurement and comparison matter? Is it just academic trivia for astronomers? Not at all. This data reveals something epic about our future. The Andromeda Galaxy and our Milky Way are not just neighbors. They are gravitationally bound to each other. Right now, they are hurtling towards one another at a staggering speed of about 110 kilometers per second or 68 miles per second. That's fast enough to travel from New York to Los Angeles in under a minute. This cosmic dance is destined to end in a spectacular collision. In about 4.5 billion years, our two galaxies will begin to merge. It won't be a violent crash in the way we think of it on Earth. Because galaxies are mostly empty space, the chances of individual stars actually hitting each other are incredibly small. Instead, it will be a slow, graceful, and powerful gravitational tango that will play out over hundreds of millions of years. The immense gravitational forces will warp, stretch, and completely reshape both galaxies. Stars will be flung into new orbits, and new waves of star formation will ignite as gas clouds are compressed. Eventually, after this grand cosmic merger is complete, a new, even more massive galaxy will be born. Scientists have playfully nicknamed it Milkdromeda. It won't be a beautiful spiral like the galaxies we know today, but rather a giant elliptical galaxy, a smooth, featureless ball of trillions of stars. Our solar system will likely survive this event, but our night sky will be forever changed, filled with an unprecedented density of stars from what was once two separate galaxies. It's a mind-bending glimpse into the distant future of our cosmic home. So, to wrap it all up, how big is the Andromeda Galaxy? It's a colossal spiral, significantly wider than the Milky Way and boasting trillions of stars. While its total mass is comparable to our own, especially when you factor in dark matter, it's a true giant of our local universe. More than just a distant object of beauty, it is our future dance partner in a cosmic event that will reshape our corner of the cosmos. The universe is always in motion, always changing, and we are just along for the incredible ride. Thank you so much for joining me on this deep dive into the Andromeda Galaxy. If you found this as fascinating as I do, don't forget to hit that like button, subscribe for more cosmic adventures, and ring the bell so you never miss an update. Let me know in the comments what other cosmic mysteries you'd like to explore next. Until then, keep looking up.